These are foam cores. They're extremely light. They come from Europe. They're CNC machined. It's a 69-inch core. It only weighs 14.6 ounces. So you can see how light they are compared to the old cores that used to be 3 to 4 pounds. We also use the same material for a lightweight trick ski. It's extremely important in swing weight in the ski, and very expensive material, and also CNC machine. This department here is where they do the cut and wrap, and all the templates for all the different size skis are on the wall. They pick each template. They're all cut independently.
Take a look at that. Where are those templates?
Templates. These templates are used to cut the carbon and the glass.
Oh.
We use one ply of very, very fine glass to give the carbon a chance to do its work. Some of these templates are different patterns for flex, where you want to take flex out, put flex in. They vary considerably. The carbon can be 12 ounce, can be 9 ounce, all various weights of carbon in different parts of the ski, cut in different shapes to get the exact right flex, torsion, stiffness.
Alright.
This fence ladder automatically holds it down, automatically centers it. Come back here, turn on the rudder, we're out the pin slot. This is a typical flex machine that the industry uses. This particular one is a little different. I designed it where I could come straight in. I don't have to come in from the end. And all the dimensions are the same as everybody uses, so that, or most everybody uses. There's a couple exceptions out there, so you can compare them to the other companies' flex zones. This table here is a granite surface plate, Boeing approved. It's within 1/10 of 1/1000 flat. We check all of our skis on this for rocker. We weight the rocker. There's a mark where the weight goes. You check the rocker with digital height gauge, so we're absolutely sure we get the exact right point. So we know exactly what the rocker is. This table never moves. It is flat. We also check flat spot, which is important. And we check that with these feel gauges. Boom, make a mark, measure the flat spot. Every single solitary ski gets the same treatment. We also check an area in the back with 1/4 of an inch. We check the area in the front the same. So we know where the taper starts and where the rocker is and where the flat spot is on every single solitary ski. It gets recorded on this piece of paper and follows it through all the way until the serial number gets on the ski, so that it can always be traced back to the paperwork that follows it all the way through with all the dimensions, the day it was made, and the layup that it was made with. So that's completely traceable. These are these are our press department. We have various presses to do different jobs. This happens to be a trick press for molding trick skis. This happens to be a slalom press molding helix. Actually, right now, another slalom press doing the same thing. This one's open, so you get an idea that it's a highly precision machine tool. All CNC machine. This press here is special for guitar necks. We build guitar necks for a very high-end company called Rainsong. And very close tolerance. This is an extremely hard operation. Took us 2 years to develop it, but it works extremely well, and they're a very successful company. Another trick press, another trick press, and another trick press. As you can see, we have a lot of presses, but we have a reason to have a lot of presses. We're molding honeycomb in this one. We'll be molding foam in this one. This is the hard edge tool. That's a honeycomb tool. Here he's cutting carbon to go inside of the trick skis. It's okay. Keep working.
Don't show any secrets.
We also have a press here that is for molding honeycomb. Trick skis. One of the things, John, that we passed by is this rim machine.
Urethane foam machine.
It's a urethane reaction injection molding machine. Very expensive, build a very high quality foam core. That core we do not use in our skis, but we do use it on other products like the guitar necks, and there's some other products that we make that require this machine. But it's a very high-tech, very good machine. I don't know, in its day it's probably $200,000–300,000.
So Denny, is that very similar technology as what you would have used back when you made PU core slalom skis?
Yes, that machine would have been a real handy machine to have back in the kidder ski days, because we used to weigh out part A, part B, and mix it with the mixer. This is an automatic mixing head on it. The key about this machine is it's called an L impingement head, and the reason for that is when you talk about chemical waste, when you have the older rim machines, they flushed out with solvent, which caused you to have a lot of chemical waste. This is our chemical waste after a shot in my hand right here.
Wow.
That's all we have. And that's not chemical because it has already been turned into foam, so you can throw that in the garbage. We don't have chemical waste. We've done a real good job of eliminating that from our shop. We use hot water and a special soap to wash your hands, so we cut down on the acetone use. We've done a lot of things to stay away from chemical waste products when we get done with our product. This is our insert department. Dave will get a template. We have individual templates for each ski to locate the inserts. Now he's going to install the insert after he deburrs the holes. So we get an absolute flush fit. Anyway, you got any idea what it costs in tooling to run a company like this with as many models and sizes as we have? You look up here, here's some of the stuff that we've cut and recut and still in production. And you come over here, you get an idea of a whole other set of tooling that's still in production. And you walk by all those presses that had tools in every one of those presses, and you're talking a lot of thousands of dollars per mold. So there's a considerable capital investment just to have a size run.
Danny, what does a slalom mold weigh?
I believe 1,200 pounds, yeah.
So you got a little forklift to move them around?
Yeah, right there, Big Joe.
Oh, there we go. There it is.
Big Joe.
Big Joe was bought in 1973 and has followed me ever since.
So Danny, I hate to disrupt some work here, but
Okay.
talk to me about this honeycomb slalom trick ski.
Okay, he's putting a rubber edge. This is a honeycomb trick ski that's been molded top and bottom. Now it's getting a rubber edge put on it, which is a very labor-intensive process. You have to make sure that you're getting your adhesive real good all around, and it ends up when we won't be here that long, so I'll just explain it to you. When he gets all that adhesive on there, he then puts a rubber edge on. This tape down here is to hold it in place while we put it in a vacuum bag, and then you have to suck it in the vacuum bag, put it in the oven and cure it. So it's a very labor-intensive process. That's one of the reasons these things are so expensive. But if we're going to build the best, we got to build it the best we can build it.
Add on all the jumpers and trick skis. So we'll adjust this for trick skis. You put the trick blank on here, the honeycomb anyways. You're going to put the template on there, grab your appropriate router and go around the outside of it, which then will give you your edge that you just saw them put the edging on. We do the same thing with jumpers, which is here's all your templates. You lay your jumper on there, which is just going to give you the blank, and then you're going to put the template on there and route it all out, and you're going to basically finish up the edge with urethane edging.
Where's that 250-foot template?
Yeah, the 250 template is going to be right here.
That's the one we want.
Yep. Freddy's.
Yeah, we had the 150-yard jump from Sue Lipagos, so we broke a milestone at 150 for the women, and then 250 with Freddie. I was pretty happy about that.
I bet you are.
There's one more thing that we do when we put the edge on these that takes a lot of time, but these tips are not just put around here square. We have to route this on an angle. Then we come down and hand shape that to get that aerodynamic lift on the tip. So we still do that.
And you said hand sanded, correct?
Yes, it's that's an artiste. Basically, he sits here and he just rolls that edge around until it gets perfectly shaped, like a blowing airplane wing. The air comes over it and lifts it up, and your tips rise up right in front of you. And that's the whole idea of that tip.
Fantastic.